This is the laboratory exercise number 7, temperature sensing. Temperature sensing is the way we determine how hot or cold something is using a device called a temperature sensor. Aside from relying on human touch, which can be inaccurate, these sensors provide exact measurements by converting heat into signals that can be read and understood. It also works by detecting physical changes caused by temperature, such as variations in electrical resistance, voltage, and emitted heat energy. Through this process, temperature sensors allow us to observe and control conditions in a more precise and reliable manner, which is essential in both simple and complex systems. This laboratory exercise was carried out using alternative software applications, particularly Tinkercad and Arduino IDE, to simulate a temperature sensing system with an LM35 sensor and an Arduino Uno, since actual laboratory materials or the Arduino kit were not available. I used these platforms as a practical and resourceful way to still perform the activity and understand the concepts of temperature sensing. In Tinkercad, I personally designed the circuit by connecting the LM35 sensor to the Arduino Uno. The 5 volts pin was connected to the Arduino supply or power supply, and the ground or GND pin was connected, and I attached the out pin to analog pin A0 to allow the sensor to send temperature readings to the microcontroller. Through this virtual setup, I was able to observe how the sensor works and how temperature data is transferred within the system. In the process of completing the circuit design, I used the Arduino IDE to write the provided code from the lab manual and test the program needed for the simulation. The code was created to read the analog value from the LM35 sensor, convert the reading into temperature value in degrees Celsius, and display the results in a serial monitor every second. The simulation was then executed in Tinkercad to monitor the system response and verify if the output readings were functioning properly, even without the actual materials. This method allowed me to apply engineering concepts, improve my programming knowledge and circuit design skills, and gain a better understanding of how temperature sensing systems operate in an actual applications.